Good morning, students. Today in this class, we are going to talk about file system interface. It is in Unit 4 operating system subject. Okay, in this class, in this file system interface, we are going to talk about what is a file, what are the various attributes of file, what are the operations of a file, and at the same time, how we are going to access the file. All those things we are going to discuss in this topic today. Next, coming to file. See, what is a file? A file can be defined as it is a data structure which stores a sequence of records. Okay, so if you store some sequence of records in one place, then we can say it is a one file. Of course, a file we can define as a data structure. Okay. And next, files are stored in a file system which may exist on a disk or in main memory. Generally, where we are going to store the files are stored in a file systems. Where the file systems are present in disk or in main memory. See, at the same time, the collection of files is known as directory. If you take one directory, what are the contents available in the directory? Collection of files. Okay, collection of files is nothing but a directory. The collection of directories at the different levels known as file systems. Okay, so here the representation of the file system. Okay, here we have file system. In the file systems, we have different directories. In the directories, we have different files. In files, what are the contents available? Data. Okay, so this is the representations. Okay, here collection of directories is known as file system. What actually the file system will contain is data. Okay, data means files. Files means directory. Okay, so this is the representation of the file. Next one is in this file system interface, the information in the file is defined by its creator. Who will create the file? Who will define the information is in a file is a creator. The creator itself defined a file information. Many different types of informations may be stored in a file. If you take one file, the file may contain different types of information. Source or executable programs, numeric, or we can say text data, or photo, or music, or video, and so on. What are the different types of information? A file has certain defined structure which depends on its type. So generally, we have three types of text files. Three types of files, that is text file, or we have source file, and we have executable file. What is meant by text file? See here, text file is nothing but it is a sequence of characters organized into lines. Okay. So next one is, what is a source file? It is a sequence of functions, each which is further organized as a declarations followed by executable statements. If you take C language, if you are writing int a comma b comma c, it is a source file. Why? Because here sequence of we are writing the C language just like as a sequence of functions, each they again further organized as a declarations followed by some executable statements. See, at the same time, what is the executable file? See, executable file is nothing but it is a series of code sections that the loader can bring into memory and execute. See, if you take a C language, initially we have source file. That source file, after compilation, we are going to get one file called as exe file. Okay, what that exe file will contain? The code section that can load what that executable file will contain is a series of code sections that the loader can bring into main memory for execution. Okay, so what are the various file attributes? If you take one file, a file may contain different types of attributes. The attributes are name, identifier, type, at the same time location, size, protection, time, and data. See, what is meant by name? Every file carries a name by which the file is recognized in the file system. See, if you take file system, in order to recognize a file, definitely a file may contain one name. That is nothing but file name. One directory cannot have two files with the same name. Okay, if you take one directory, DBS is one directory. In that DBS directory, we can't keep two files with the same name. In the DBS directory, we can't place ABC. Why? Because ABC is the two different file names. We can't keep these two file names in the one directory, that is DBS directory, for example. Okay, this is the name of the file. Next one is identifier. See, along with the name, each file has its own extension with identifier, which identifies the type of file. Here, identifier means whether the file is a text file or executable file or video file or audio file, like this. Okay, so each file has its own extension. By seeing the extension, we can identify the which type of that particular file. For example, here a text file has the extension .txt. Generally, if you take one text file, what we are going to save the text file is .txt. A video file is .mp3 or mp4, like that. Okay, so this is the identifier. Next one is type. Okay, so here in the file system, the files are classified into different types, such as video files, audio files, or text files, or executable files. Okay, so what type of that particular file is? A file is, it is the audio file, or it is a text file, it is a video file, like this. Okay, so these are the this is the type of the file. Okay, so next, coming to the one more attribute, that is location. So here, location means in the file system there are several locations on which the files can be stored. Each file carries its location as an attribute. Okay, so there are so many locations on which a file can be stored. Okay, definitely we have a file. If we want to store that particular file, definitely we need one location. It is nothing but location. So what is the size? Next one is size. The size of the file is one of its most important attribute. By size of the file, we mean that number of bytes occupied by the file in the memory. See, by seeing the size of a file, we can say how much memory that particular file is going to be occupied into memory, either 10 kilobytes or 20 kilobytes, like this. Okay, so this is the size is one attribute. So next one is the protection. See, a file may have, if you have a file, we need to protect those files. Okay, here protection in the sense, the admin of the computer may want the different protection for the different files. Okay, therefore each file carries its own set of permissions to the different group of users. Okay, for example, if we take one system, for example, I am the admin of the system, I can give permissions to some of the files. Okay, that means I am going to protect some of the files as the admin. Okay, so that is nothing but protection. Okay, protecting the files from unauthorized one. Okay. Now this is one of the attribute. Next one is time and date. So every file carries timestamp which contains the time and the date on which the file is lastly modified. Okay, or lastly created. Okay, each and every file will have time and date. Okay, if you take one folder which was created earlier by you, if you see that folder, one file name, beside that file name you have a time and a date, which date you are going to create, which time you are going to create. Okay, so all these are the various attributes of a file. If you take a file, all these are the various attributes we have it contains. Okay, so next one is operations on files. What are the various operations on files? Is create is one operation, write, read, reposition, delete, and truncate. All these are the various operations of a file. See here, a file is an abstract data type. To define a file properly, we need to consider the operation that can be performed on the file. Okay, so first one is create. So creation of a file is the most important operation on the file. Different types of files are created by different methods. For example, text editor are used to create the text file. If you want to create the text file, we need text editor. Or if you want to create the word file, we need word processor. Or if you want to create the image file, we need image editor, like this. Okay, so next one is write. See, what is meant by write? Writing the file is different from creating the file. The operating system maintain a write pointer for every file which points to the position in which file from which the data need to be written. Okay, the operating system will maintain one pointer from where onwards we are going to write that particular file. The next one is read. Read is also one of the major operation. Whereas coming to read, every file is opened with 3 different modes. That is read mode or write mode and append mode. A read pointer is maintained by the operating system, pointing to the position up to which the data has been read. So this is the major 3 operations comes under file. Next one is one more operation, that is reposition. So repositioning is simply moving the file pointer forward or backward depending upon the user's requirement. It is also calling as seeking. Okay, based on the user requirement, you are going to move the file pointer either forward direction or backward direction. Whereas the next one is deletion. See here, deleting the file will not only delete all the data stored inside the file. It also delete all the attributes of the file. If you are deleting the file means it will automatically delete all the attributes associated with that file. The space which is allocated to the file will now become available and can be allocated to another file. Okay. See, for example, if you are deleting the one file means the space which are allocated to that file was now vacate. That means free. So that free space we are going to use it for another file. Whenever we are deleting the file means automatically we are deleting the attributes of that file. Okay, either space or size like that. So next one is truncate. Here truncate is nothing but it is deleting the file except deleting the attribute. Okay, we are deleting the file except deleting the attributes. That means we are not deleting the attributes. The file is not completely deleted, although information stored inside the file get replaced. Okay, so these are the various operations on file. Okay, so next coming to file type. See, a common techniques for implementing file types is to include the type as a part of the file name. The name is split into 2 parts, a name and an extension separated by a period character. The system uses the extension to include the type of the file and the type of the operations that can be done on that file. Okay, here we have different file types along with user extensions and functions. Okay, so here the executable file, if it is executable file type, then the extension is exe or .com or bin, or for function of the executable file is read to run machine a language program. Next one, if it is object, the extension is obj or o. Function is compiled and machine language not linked. If it is source code, the extension is C or CC or Java or Perl. We can say we are using any one of the extension. A source code in various languages. Okay. So next one is batch, markup, word processor, library, print or preview, archive, multimedia. All these are the various different file types along with user extensions and along with functions. Okay. So next coming to file structure. See, what is the file structure? Here file types can be used to indicate the internal structure of the file. Source and object file have structure that match the expectations of the program that read them. Certain files conform to require a structure that is understood by OS. But the disadvantage of having the OS support multiple file structures is that the resulting size of the OS is cumbersome. Okay, if the OS contain 5 different file structures, it need to contain the code to support these file structures. Hence, the operating system impose a minimal number of file structures. Mac OS also support a minimal number of file structures. If you take a Mac, it support minimal number of file structures. It accepts files to contain 2 parts, a resource fork or data fork. The resource 4 contain information of interest to the user. The data 4 contain program code or data traditional file content. Okay. So next coming to internal file structure. So what is meant by internal file structure? So internal file structure is nothing but it is internally locating an offset within a file can be complicated for the operating system. Disk systems have a well-defined block size determined by the size of the sector. All disks I/O is performed in unit of one block and all blocks are the same size. Since it is unlikely that the physical record size will exactly match the length of the desired logical record, and then logical record may even vary in length. Packing a number of logical records into the physical block is one of the solution. The logical record size, physical record size and packing technique determine how many logical records are in each physical block. The packing can be done either by the user application program or by the operating system. Hence, the file may be considered to be a sequence of blocks. All the basic I/O functions operate in terms of block only. Okay. So next coming to access methods. Files are stores the information. When it is used, this information must be accessed and read into computer memory. The information in the file can be accessed in many ways. Okay, one of the major different ways are sequential access. We are going to access the file as sequential, direct, and next one is indirect access. Okay, so these are the three different type of accessing techniques. So whereas coming to sequential access, sequential means one by one. Okay, so simply one by one. Most of the operating system access the files sequential only. In other words, we can say that most of the files need to be accessed sequentially by the operating system. Okay, all the files can be accessed sequentially by the operating system itself. Okay, in sequential access, the operating system read the file word by word. Read the file word by word. A pointer is maintained which is initially point to the base address of the file. Okay, initially we have a pointer. That pointer points to the base address of the file and starting address. It means starting address. If the user wants to read first word of the file, then the pointer provides that word to the user and increases its value by one word. That is for next word. This process continues till the end of the file. Modern word systems do provide the concept of direct access and indirect access, but the most used method is sequential, because due to the fact that most of the files such as text file, audio file or video file, etc., all those things need to be sequentially accessed. Okay, see here, a file may contain totally 8 file 1, that is this is file 1, file 2, file 3. Okay, all these files can be accessed sequentially. That is, first of all, file 1, again after completion of file 1, then go for file 2. So next after completion of file 2, next go for file 3. Okay, of course a file may contain different a file may contain data. Okay, that is data 0, or we can say that one also is file 0, file 0, file 2, file 1, file 2, file 3, like this. Okay, 8. If again file 2 have file 0, file 2, file 1, file 2, file 3, file 4, like this, file 8 up to file 8. Okay, like this. Okay, see here in this sequential access, first we are going, first the pointer is at the base address, that means at the file 1. Okay, if after accessing the file 1, next it will go to the file 2, like this. Okay, sequentially we are going to access the files. Okay, here also sequential access, file 1, file 2, file 3, file 4, like this. Okay, so this is the accessing methods. So this accessing method will support some of the operations. Okay, that is read next, write next, or we can say rewind. So what is meant by read next? Read a record and move pointer to the next location. Okay, this is one of the operation. Next, write next means it is also same as read next. In this we write and advance the position. Okay, we are going to write and advance the position. Whereas next one is rewind. See, in this rewind, to see we have current position. Rewind means back, read or write. Okay, so this is the beginning, this is the ending. To move forward direction, use either read or write. To move to the beginning use rewind. That means moving back to earlier location. Okay. So rewind means, for example, if we are current location, we are going to move back. That is nothing but a rewind. So it is the rewind. So next one is, we have one more operation also, that is skip n records. We can skip n number of records if possible. For example, we have 2 records. If we skip, if you say, for example, skip 2 from current location, then 2 locations are skipped. Okay, so this is regarding sequential access. So next one is direct access. See, what is meant by direct access? So direct access is mostly required in the case of database systems. In most of the cases, we need filtered information from the database. The sequential access can very slow and inefficient in such cases. Okay, so it suppose every block of storage stores 4 records, and we know that the record we needed is stored in 10th block. In that case, the sequential access will not be implemented, because it will traverse all the blocks in order to access the needed record. Okay, so direct access will give the required result despite of the fact that the operating system has to perform some complex task, such as determining the desired block number. However, that is generally implemented in database applications. It allows, direct access allows random access. Okay, random means it is nothing but direct only. User can jump any record and access that particular record. Okay, there is no sequential. Okay, user want the 10th record, they can directly access the 10th record like this. Oh, there is no sequential manner in this direct one. So in this direct access also, we are going to use some operations. That means this method, direct access method, supports some of the operations, that is read n, write n, jump to record n, next query current record. See, what is meant by read n? See, it is nothing but, read n is nothing but reading a record number n, reading a particular record. So for example, read 10 means reading a 10th record. Write n means writing a record number 10. If n value 10. So next, jump to record n, that is jump to a particular record. For example, jump to record 5. That means we are going to jump the particular record 5. Next, query current record. It is used to return back to this record later. Okay. So all these are the different methods that support different operation that supports the direct access. So next one is indexed access. Okay. So in this indexed access, if a file can be stored on any one of the field, then an index can be assigned to a group of certain records. However, a particular record can be accessed by its index. So we have index. By using the index numbers, we are going to access the particular record. The index is nothing but the address of the record in a file. Okay. So here index is nothing but it is the address of a particular record. Okay. So this index, what the index will contain? Address of a particular record. Okay. For example, I want to access particular record. See, by seeing the index only, I am going to access that particular record. Why? Because the index may contain the address of the record in a file. Okay. So this is the representation of the indexed access. So in indexed accessing, searching in a large database became very quick. Okay, why? Because we are using the concept of index and easy, but we need to have some extra space in the memory to store the index value. Okay, index is created which contain key field pointer to the various blocks. Okay, so here primary index. Next one is index pointer. Here employee one tabular column, that is employee number, employee name. Okay, job and hire date, salary, department number. So for example, employee, these are the employee number. Okay, various records are there. That corresponding records address are in the index. This is the index table. Okay, by seeing the index, we are going to find out the address of a record in a file. Okay, so these are the various accessing methods. That is sequential access. So next one is direct access. So next one is indexed access. Okay, so the major difference between sequential and direct access means in sequential we are going to access the records in a sequential manner. We can't jump to a particular file, or we can't jump to a particular record. Okay, whereas if it is a direct access, so we are going to access a particular record directly. For example, if I have 10 files, if I want to use the file number 4, okay, so if it is the sequential means, first I have to access the file number 1, file number 2, file number 3, file number 4. Okay, if it is direct means, no need to access the file number 1, file number 2, file number 3. Okay, directly we are going to access the file number 4. Okay, so you can say it is a direct access. Okay, so all these are the various accessing methods. Okay, so thank you. Next class we are going to talk about regarding a directory. So what are the directories and disk structures, how we are going to implement the directories. Okay, thank you.